Welcome to this distinguished lecture of WISP. So today's speaker is Elissa Redmiles. She's a faculty member and research group leader at the Safety and Society Group at the Max Planck Institute for Software Systems. So Elissa is not your usual, security scientist. She doesn't just use computational method, but also like economic and social science method to understand, crucial security and privacy aspects. And I'm really looking forward to the talk today about contact tracing. Elissa's work has been distinguished in many ways. She got Best Paper Awards at Security, Facebook Research Award, or the John Carrot Usable Privacy and Security Research Award. So, Elissa, really looking forward to your talk. Thanks.
Thank you. Thanks for having me, and thanks for the kind introduction. So today I'd like to talk about encouraging adoption of contact tracing apps. And the work that I'll present today is part of a collaborative project across a number of institutions, including Max Planck, as well as Microsoft Research, the University of Maryland, University of Zurich, Boston University, and the University of Michigan. And if you are interested in some of the things that I speak about today, I have the URL up here at the top where you can find kind of more of our work. Okay, so to kind of kick us off, we should talk about computational problems in general, right? Not just contact tracing. And when we think about these computational problems, as most of us experience, they require kind of constant decision making. So we have to decide what features are fair or effective to use in a machine learning classifier. And similarly, we have to decide what data is appropriate to use, how to protect it, and which features to prioritize in things like contact tracing apps. And typically it's experts who set these best practices. So security experts, for example, or machine learning experts in ML classifiers or in contact tracing apps, or public health experts who might think about what information they need in order to accomplish certain public health objectives. And prior work has suggested that when experts make these decisions, they are trading off, say, a benefit to public health against risk to individuals. And the experts make some sort of normative decision here, and that is what informs, say, what data they choose to use or what data they choose to release publicly, etc. And experts do not always agree on the best practices. So we've seen numerous cases where experts disagree about various types of feature usages in machine learning, ways to protect end user security, or whether or not to use things like digital contact tracing. But even more importantly, users and experts may disagree. So an expert's perception of the trade-off between benefit to public health and a risk to an individual might be quite different from how end users might trade these two things off. And this tension between sort of experts' prescriptive best practice and what end users might want is a tension that has existed well before there were any sort of computational solutions. This is a tension that is discussed frequently in literature on moral philosophy, where they're discussing how sort of norms and rules and laws were created over the past many centuries of human existence. And so they talk about kind of two different approaches. One is normative, where these experts are prescribing what they think is best for the population. And the other is descriptive, where we sort of learn from non-expert or population preference and behavior, and we infer best practice. We try to align ourselves with that behavior. And of course, you don't have to necessarily pick one or the other of these approaches. We often kind of try to find something in the middle. And so today I'll talk about various kind of descriptive ethics approaches or lenses through which we tried to look at defining acceptable functionality and appropriate sort of ethical ways of trying to get people to adopt things like contact tracing apps. So as all of us are probably aware at this point, right, there was an influx of development on contact tracing applications toward the beginning of the COVID-19 pandemic. And one of the interesting things about these contact tracing applications is that the benefit of their use scales quadratically with the number of users. And so this chart that I have here on the right is from some early research put out by the University of Oxford, where they were trying to model how a particular prevalence of app uptake in a population might influence the number of cases. So as app uptake increases, as we go toward the yellow bar, we see that the number of new cases decreases and that this decrease is exponential. And so what this means is that even more than usual, we really care about people having uptake of this technology, and uptake is quite critical to whether or not it effectively achieves its outcomes. At the beginning of the pandemic, when all of these apps were created, right, experts were highly focused on ensuring that these applications protected user privacy, because of course they can be used as sort of surveillance measures. And so there was a lot of conversation and technical development around privacy. But of course, privacy is not the only reason why someone might be willing to adopt or not adopt an app. We have many other reasons for any kind of app or technology in our life for adopting. And so our project really focused on trying to identify people's adoption considerations, to predict levels of adoption and prioritize those considerations in order to create sort of benchmarks for those who were developing these apps. And then we wanted to actually put our findings into practice to try to directly improve adoption of these apps, particularly through both their design as well as how they were marketed. And I'll talk about projects that we had on each of those pieces today. Okay. So how did we start out? Well, we started at the very beginning of the pandemic with trying to understand why people might or might not want to install these apps. And at the time, the apps did not exist. And so as a result, we needed to use surveys to ask people about these kind of hypothetical technologies. And so we carefully designed both closed answer questions, which is where people pick from a number of options, as well as open answer questions where they just sort of verbally describe their reasoning for why they would or wouldn't want to install. And we wanted to make sure that we kind of broadly sampled opinions from the population we were interested in, which was the United States. And so we made sure that our surveys covered people whose demographics matched those of the US Census. And with these surveys, what we found was that there are many possible kind of adoption inputs in people's decision-making. So the first was the benefits. What is this app going to do? Of course, contact tracing apps have both individual benefit in terms of knowing your risk and therefore being able to, say, protect your loved ones, and societal benefits like knowing your risk, quarantining, and then not spreading it to others. People cared about who was providing the app. So things like contextual integrity theory tell us that people have different level of trust for different information flows. I'll get to that in a minute. And one of the key pieces is who is the information going to? Of course, people did care about privacy. So experts were correct in focusing on that, although of course it was one of multiple considerations. People also cared about mobile costs. So things like how much was the mobile data usage going to be, which can be quite a bit more expensive in the United States than it is in Europe. People also cared about how accurate the app was. So thinking about those benefits, well, is it really going to deliver on them? Is it going to be accurate? Is it going to be effective? And finally, closely related to privacy, people cared about security and agency. Am I going to be able to delete my data? Is it going to be safe? Is it going to get hacked? Diving a little bit deeper here, when we think about like the provider, what we find is that at least in the United States, there was sort of not a universal preference for any one provider. So what you see here in this chart is in dark blue, the proportion of folks who were only willing to install an app from that provider, and in the light blue, folks who are willing to install an app from that provider as well as others. So the largest proportion of people were willing to install an app from a health protection agency, but that was still just under 40%. We did run this particular piece of the study in Switzerland and Italy as well. And there we see quite different results. So we actually see that more than 50% of people were willing to install an app from the federal government. And so you see kind of a difference in terms of people's trust of government and who they want providing the app in the United States versus at least those two countries in Europe. What the implication of this is that it was a good thing that the United States and sort of the Google Apple framework, which was one of the main ones for contact tracing, went with having health protection agencies provide the app. It also makes sense with existing theories that say that people like to kind of have cohesion in terms of what data they're sending to whom. So it makes sense to them to have health data going to a health protection agency for a health purpose. That said, you still have a good portion of the population who's not so comfortable with a health protection agency. And so this was absolutely kind of something that factored in to why people did not adopt these applications. Beyond sort of the provider, the top sort of 3 motivations that people had for wanting to install a COVID app was to stay informed about COVID-19, to support the fight or protect the public, so sort of a social good, or to protect themselves and their loved ones, so like an individual motivation.
Sorry, I have a question. Can we interrupt or should we ask questions at the end?
Feel free to interrupt.
Yeah, the point protecting the loved ones, I'm not sure if I buy that argument. I mean, if my loved ones, I usually am in contact with them, so why does the contracting app, why do people consider a contract tracing app useful to protect the loved ones? What's the argument there?
It's a good question. So there's sort of the answer in terms of what is true about what will protect, and then there's of course people's perceptions about whether it will protect. So in terms of how it can actually protect loved ones, we did see people talking about, say, having elderly parents who did not live with them. And so they hoped that a contact tracing app would inform them, so before they went for their weekly dinner, they would know not to go if they had been exposed. There's also sort of the perception piece, which is in crises, people really like to have more information, and it does make them feel safer or feel more in control and more able to protect those they care about. And so some of this is just a perception of safety versus a real safety.
Okay, so these are not arguments from your side, this is perceived arguments from the people.
Exactly, yeah.
Okay.
Yeah.
Thank you.
Yeah. Awesome. Okay, and so in terms of why people did not want to install, we see a large proportion, over 30%, who either didn't believe in COVID. So remember, these surveys were run around March to May of 2020, so pretty early on. And the US has some challenges with sort of science knowledge and beliefs. So people either didn't believe in COVID or they were overwhelmed by it. And so we saw people saying, you know, I'm already hearing so much about this pandemic, I just can't stomach installing one more thing that's going to remind me of it. We also saw privacy concerns as kind of the second most prevalent reason. So absolutely good that that was a focus in the development. And then next we see either those mobile costs or people saying, I just have a practice of not using apps and I'm not going to use them for this. And then finally, we see accuracy concerns and then security concerns. Okay, so that's great that we have all of these different considerations, but in an application development lifecycle, particularly one that's happening during a crisis situation, we need to prioritize what we're going to focus on. And so next we wanted to understand which of these considerations mattered the most. And in order to answer that question, we used a methodology called conjoint analysis. And this is a technique that comes out of quantitative marketing. So marketing researchers, both in academia and in industry, will try to understand what products should be released to market. So if I am exploring what televisions to release to the market in 2023, then I might want to know how people prioritize, say, number of pixels against screen size, against price, etc. And so what I will do is I'll have them make a number of decisions where I show them two products with different kind of quality for different features, and they'll be able to pick one of those two products or neither, and they'll make a number of these decisions, and from their decisions I'm able to infer how important they find price versus pixels versus size versus whatever it is with the television. We use the same technique but with contact tracing apps. So what we told people was, imagine that there's a mobile phone app intended to help combat coronavirus in the United States. Different apps have different benefits and risks and may collect different types of information about you. Please look carefully at the options below. Each column represents an app with different attributes that will be designed and distributed by a health protection agency. So we didn't vary who the distributor was because at this point, the US had come out to say it was only going to come from health protection agencies. Assume both apps are equally popular, which one would you choose? And then we offered them different choices with different values for each of the features that we had identified based on people's descriptions were important to them in the prior research study. Based on people making a number of these decisions, what we're able to do is we're going to able to say, in the average case, what does people's intent to install depend on? And the answer to that question is that about 30% of people's consideration is privacy and data use considerations. And an equal proportion is considerations about accuracy. Does it do the thing that it claims to do, or does it do the thing that is most important to me? We also see the remaining considerations being spread across costs like mobile data use and battery life, as well as how the app was framed in terms of benefits. So getting back to the question that was asked, is it framed in alignment with what I think it does or not? Okay. So of course, that's kind of the average case. And part of what it shows us is that if we had focused just on privacy, we would have missed about 70% of what people were actually thinking about in terms of whether to install. Now, everyone doesn't value these attributes equally. So if we look kind of beyond the average case, we see some differences based on political leaning, with Democrats focused more on accuracy, Republicans more on privacy. Republicans in general in the US have trended toward being more privacy focused, so this is not super surprising. We see differences among younger and older adults. And finally, we see some differences among those who are more knowledgeable or more engaged with COVID news. So those who are more knowledgeable and more engaged were more focused on things like accuracy and benefits. Those who are less engaged were more focused on privacy. And our hypothesis here is there was actually a lot of news about all of the different efforts that were being done to protect privacy in these apps. But if people weren't super engaged with that, then they may not have known and might have still had those kind of lingering privacy concerns. On the other hand, those who understood more things about how COVID-19 spread were more focused on, well, is this app really going to be able to detect exposures? Okay. So now we know, okay, what are people considering? Which are the things most important to them? Privacy, accuracy, a bit how it's framed, a bit what are the costs? Can we predict when adoption intent is high enough to release? How do we know, when this is going to be good enough for release? And for this question, we focused on the two most important aspects. So we asked the question, how much privacy and how much accuracy is required for people to want to adopt? So can we predict adoption intent based on the level of privacy risk and the degree of accuracy? Okay, so in order to answer this question, we surveyed nearly 4,000 crowd workers, and we also surveyed kind of general end users who match the demographics of the US again. We use that to validate that the crowd workers were giving similar answers, and we do find that validation. I have a link to the paper if you're curious about that piece, but we did use crowd workers just because of the scale of these experiments. Okay, so we wanted to predict adoption intent based on quantified privacy and accuracy. And so what we did is we first wanted to address false negatives, right? So there's two kinds of, accuracy we might care about, false positives and false negatives. And so we first need to understand, how private do people think these apps are? And in order to ask that question, we use a pre-existing validated measure that's used for assessing all different kinds of risks, like people's perceived risk of developing cancer or their perceived risk from smoking, et cetera. And so we told people, studies show that despite best attempts to protect the data of those who use this app, some people may have information about who they have been near compromised and used for purposes other than the fight against coronavirus. Please indicate on the chart below how many app users you think will have this information compromised over the next year. And so they're able to pick one of these regions, so between 1 in 10 and 1 in 1, 1 in 100 and 1 in 10, and you'll notice that the regions have anchoring risks. So like the risk of receiving a speeding ticket, the risk of having unattended property stolen, et cetera. These risks are all crimes because they're mapped to the same kind of domain space as a privacy leak. So if it was like a health risk, it would be things like being struck by lightning, et cetera, that are sort of physical harms. Okay, so people indicated their implicit privacy perception, and I'll talk about in a minute how we validated that they actually held these privacy perceptions. We then told them a specific false negative rate. So we said, imagine that you're exposed to someone who has coronavirus 100 times over the next year. If you do not use the app, 1 in 100 times, public health workers will be able to detect and notify you that you were exposed. If you use the app, and we gave them some number, so some true positive number of times, out of 100 times, the app will be able to detect and notify you that you were exposed. Would you install this app? And what we're relying on here, and the reason we're saying n out of 100, where n is some real value, instead of saying like X%, is that there's a lot of research in the space of numeracy, which talks about how people understand numbers. And the general consensus is that people really do not understand percentages, but they can understand counts out of 100 or counts out of 1,000. And so that's what we're using here. Again, a lot of these techniques come from other health risk spaces where they're trying to communicate to people how likely they are to develop some negative outcome. Okay, we want to do the same thing for false positives, right? So we do the same implicit assessment of privacy, and then we give them a false positive rate. So we say, imagine you're exposed to someone who has coronavirus 100 times over the next year. If you don't use the app, same thing, 1 out of 100 times, public health workers will detect and notify you you are exposed. The app is not perfect. If you use the app, it will correctly notify you every time you are exposed. So we have a perfect true positive rate. But the app will also incorrectly notify you an additional false positive number of times when you are not actually exposed. And recall that at this time, if you were notified that you were exposed, you were supposed to quarantine. So there's a fairly decent potential repercussion from these false positives. Okay, finally, we wanted to make sure that people were actually operating based on these privacy perceptions that they were giving us. And so we wanted to do sort of a counter check to say, well, what if I told people what the privacy risk was, and I told them the same false negative rate as in the first experiment, then their answer should be the same, right? So if their belief about the privacy perception combined with the false negative rate I tell them leads to them saying, no, I'm not going to install this app, then if I tell them the privacy risk is what they assume it is and tell them the same false negative rate, they should have the same response. So in that case, we said, studies show, despite best attempts to protect the data of those who use this app, some people may have information about who they've been near compromised and used for purposes other than the fight against COVID. P out of 1,000 people who use this app will have this information compromised. And we set P based on kind of the distribution of people's privacy perceptions. We did the exact same false negative rate. Okay. So after we ran all of these surveys with a spread of different values for the false negatives and false positive rates, we were able to build predictive models for how likely people were to install a COVID app given some level of accuracy while controlling for a level of privacy. And we're able to get decent predictive accuracy, so around 70%, which sounds terrible if you work on kind of machine or biological data, but is actually quite good for human behavior, where we're rarely able to get sort of over 60% predictive accuracy. So we're able to predict fairly well people's intent to install. Now recall, this is intent to install. This is not actual installation. And so what I would take from this is not necessarily absolute values, but sort of trends. And so the trends that we observe are, if the app is at least 50% sensitive, you have a 50% true positive rate above a baseline kind of 1% detection rate, then a majority of people are willing to install. Your confidence interval has gotten over the 50% mark. False positives people are more sensitive to, right? So as I get more than 10% false positives in a perfect app, we're starting to see less than a majority of people being willing to install. So if I was an app developer, I would be focusing very heavily on those false positives. And that was a conversation that we did have with various different folks creating these kinds of apps. Okay. What about those privacy expectations? What we find is that people did have a priori risk expectations. So on average, they thought there was kind of a 0.01 to 0.001% chance that information from a COVID app would be compromised in the next year. This is a little bit higher than prior experiments looking at their perception of like the risk that their bank account would be hacked. So they thought this was a little bit less secure. And we do find that they were operating based on those privacy perceptions. So knowing their privacy perception improves our ability to predict whether they will install. And that little gut check experiment I talked about did work out. So basically, if I tell you what the privacy risk is, or if you tell me what the privacy risk is, you behave the same way if you're given the same false negative value. Okay. So these kind of things allow us to sort of think about how good does the app have to be? What does the accuracy have to be, et cetera, before people are going to be willing to install? Can we use this to sort of set benchmarks for when we're ready to release? All right. The final piece is we want to try to get people to install these apps, right? And a lot of times people are like, well, instead of trying to convince them to install, why don't you just kind of pay them to do it, right? We pay lots of people to participate in experiments, et cetera. And so a lot of folks, especially in the economics community, will be like, well, why don't we just incentivize them to adopt these apps? It turns out that won't really work. So what we find is that incentives will change what quality of app people will install, but it won't ultimately affect too much how many people are willing to install. So what I mean by that is in a case where we didn't provide any incentives, right? All you get is sort of the intrinsic benefits that come with the app, whether it's societal or individual. If instead we say, oh, well, we will give you some healthcare incentives, right? So in the US, healthcare is very expensive. We will pay for your healthcare premium for a month, or we will give you 3 free doctor's visits, or whatever it is. If we do that, what we find is that there's a change in sort of what quality the app needs to have. So people are comfortable with it being more costly to their mobile data. This is something economists call kind of commensurable quantities. You're saying, well, I pay for mobile data and you're paying me, so I'll just like swap those. And they care more about the benefits, but they don't care any less about privacy and accuracy, kind of their core concerns, and we don't see more of them adopted. This gets even stronger if we go ahead and we pay them and we say, hey, we're going to give you a gift card. And this is true at different levels of dollar values. People are like, okay, well, great. You can pay for my mobile data, but I care more about the things you can't compensate me for, like battery life. And this is, again, kind of a known economic phenomena that the more you draw people's attention to sort of what you're paying them and therefore what their costs are, it kind of changes their calculus. So you could offer perhaps a bit worse performing or more costly app, but you won't necessarily get more people signing up. Okay. So that kind of takes us back to how do we actually improve adoption, because we can't just pay people to adopt. Of course, we can require it, which some countries did do, but in countries where we don't want to require use of the app, we want to be able to use the results of our research in terms of what was most important to people, how they wanted it framed, et cetera, in order to try to improve uptake of the app. And so I will present one case study of one of the jurisdictions that we worked with on marketing their COVID app, which was the state of Louisiana. And so we worked with the state of Louisiana to conduct a randomized controlled field study, and we ran their Google display ads campaign for them in order to do this field study. So the Louisiana Department of Health developed an app called COVID Defense. And actually, they didn't really develop the app. A foundation called the PathCheck Foundation that came out of MIT developed this app, as well as, I believe, over 15 others that were used in the Americas. And Google display ads are the ads that you see kind of in the sidebar when you do Google searches on your mobile phone, et cetera. We ran that campaign of theirs. And in this campaign, what we did was we used 14 different messages to advertise the app. And we controlled what was put in each of these messages in order to look at the effects of different kind of appeals. So whether we appealed to individual good, get notified of COVID exposure, or to collective good, reduce COVID infections, as well as transparency. So what happens if we're transparent about one of their top considerations, privacy and in combination data collection. So we had statements like that were very broad without harming your privacy, that were focused on control, you control the data you share, or that were quite technical, app data stays on your device, or we didn't mention any privacy at all. Finally, we had transparency around data collection. That was something that popped out specifically in our earlier results in terms of people's considerations of privacy. And so if there was a privacy statement, we sometimes paired that with a statement that said the app uses information about who you have been near. We did not display any data transparency message without a privacy statement, because of course we were running these campaigns in real time at the time that the app was released, and we didn't want to unduly influence people to not adopt by just saying what data it collected without saying anything about privacy. Okay. So we ran all of these advertisements in order to understand the effect of both individual and collective goods appeals, as well as privacy statements. And I'll note that this question of individual versus collective goods appeals, while it came out in some of our results as well, right, as we discussed, this is also a thing that was at the time being debated in a lot of the policy literature around even how do you get people to wear masks? How do you get people to do any of these like pro-social health behaviors in COVID? Is it better to appeal to individual good or collective good? This also tends to be a question with other kind of mHealth or mobile health apps. Okay, so what we find is that in this context, in the state of Louisiana, a collective goods appeal was significantly more effective than an individual good appeal in terms of getting people to adopt the app. So to click on the ad to adopt the app. There's kind of two potential hypotheses for this. One is that ultimately the primary purpose of these apps is for collective good. And so there's some evidence that people are more willing to engage when advertisements are sort of forthright and honest about what the benefits are. The other sort of caveat or potential other reason is that within the United States, Louisiana is among the most collectivist states. This is true of much of the South, but particularly Louisiana, there's a very big focus on the in-group. And so there may be extra emphasis on protecting kind of others in the state, others in the in-group, that made this collective good appeal appealing. Okay, perhaps more interestingly, what we find is that depending on which appeal you showed people, there was a difference in the effect of the privacy and data transparency statements. So if you offered the collective goods appeal, then having a privacy statement improved the effect of that appeal even more. And our hypothesis for this is that in the literature, people's privacy concerns are even extra heightened in a collective case. And so having a privacy statement kind of tones those down while letting people enjoy the kind of good feelings from doing something for the collective good. On the other hand, adding a data transparency statement on top of the privacy statement, on top of the collective goods appeal, decreased the effect. And our hypothesis here is that you're really raising the saliency of the fact that you're individually contributing your individual data for this collective good. So you're really heightening the individual piece, which may erode some of those good feelings from doing something collective and may throw off kind of your privacy calculus a little bit. And I'll talk about that privacy calculus again in a moment. On the other hand, when people were shown the individual good appeal, showing them a privacy statement either had no effect in the case of the broad and non-technical statements, or had a negative effect in the case of the technical statement. And our hypothesis here is around this privacy calculus. So a lot of literature says people are doing privacy calculus in their mind. So they are deciding, they're kind of weighing the costs and the benefits. So they're saying, okay, here's the individual benefit, here is the cost to me from privacy. And so by adding a privacy statement, we're raising the salience of the privacy side of that equation even further, and maybe throwing that kind of existing calculus out of whack. On the other hand, the data transparency statement actually helped. And our hypothesis here is that in other research we've done where we've followed up with people who use the app or stop using it, et cetera, afterward, we find that a lot of people still thought the apps were using location data and a much wider array of data than what they're actually using. And so by scoping what that data use was to just people you've been near, we may be actually kind of helping that privacy calculus, scoping down people's privacy fears. And so we see overall very differential effects depending on how you frame the application. And this is relevant, we think, and we're doing kind of ongoing experiments to test, but we think that this will be relevant in other privacy related settings, that the way that you frame the application or the technology in terms of who it benefits, et cetera, is going to change how what you say about privacy or about data use affects people's reactions. Now, of course, this field experiment only tested privacy and benefits. We weren't able to test accuracy, which was also something people cared about. And the reason for that was that we ran our experiments right when the app was released so that there wasn't like any other messaging out about it. But as a result, there were no evaluations of accuracy performed before it was released. So there wasn't anything that we could accurately communicate to folks. Okay.
I have a question. Before we go deeper into advertisement strategies, I wonder what are we adverting? So, because it seems the premise of all your work is based on the assumption that adoption matters, right?
Yep. Mm-hmm.
So, is there scientific consensus on this premise, or is there also some debate on this?
Yeah, that's a great question. So there has been evaluation in Switzerland and I believe also France. I'll have to check. There was another country, as well as in Israel, all looking at the impact of kind of contact tracing apps. The study that I think is probably most useful for looking at that is one that Switzerland did within a military setting. And the reason I say it's most useful is that sort of controls for adoption. And so they did find that when it was well adopted, it was quite effective in reducing their case count. They had kind of a control site and then a site with the contact tracing apps. In other places, there have been challenges to evaluating efficacy for two reasons. One is you sort of have natural adoption, which has not been terribly high, and therefore there's not necessarily sufficient coverage, right? So some college campuses had good adoption. They've been able to evaluate a bit. The other thing is a lot of the privacy protective mechanisms that were put in place and the apps were released before anyone thought about evaluating efficacy. And so as a result, people are now having to kind of retroactively try to figure out mechanisms for efficacy, but they didn't necessarily track who was calling in with a case or who was doing contact tracing based on manual data versus based on app-based data. And so in a lot of jurisdictions, they have no separation to know what cases were caught how, or to sort of compare case counts. So from what I've seen in public health, there seems to be a view that it is, if adopted, it is effective, and that we should encourage people to adopt, but there is not as good efficacy data as we would like.
Because I think we had Professor Bart Brunel here. And as far as I recall, his conclusion was that the false confidence is a big problem. It seemed that there is if I remember correctly, he showed that there was a correlation between that the cases were even higher in regions where adoption was of the app was happened. So can you comment on this? Have we new knowledge on this problem? And what people who do not have a phone, should they then start to feel more insecure because they are not part of the system and buy a phone?
Yeah, that's a great question. And yes, actually, Bart and our group collaborated on this kind of retroactive look at how people use the apps. So that is something that has come up both for COVID and then other uses of contact tracing apps, which is often for STDs, which is sort of this false confidence feature, right? And we see this for other things like wearable safety devices. And I'd say, Bart and I have talked about this a little bit. It's sort of, right, we always have correlational data. We do see that more in those regions, although we could also imagine that there's more adoption in those regions because there is more transmission or because there are higher cases. It's often sort of hard to figure out the causality. So I'd say it's certainly something that we should explore and be cautious of. And this is actually part of why we interviewed people who had been using the apps. We didn't hear in those interviews, at least, and in other interview studies that have been done, we didn't hear a ton about people saying, oh, now that I have the app, I feel comfortable going out. But I think that is something that we would have to both continue to track and also look at in combination with sort of socio-demographic variables. So I had heard a bit of that in some of the studies on like college campuses specifically, that it's sort of like, oh, okay, I have the app, now I can go do whatever. And this is sort of often a balance we have to strike with preventative measures of, is the efficacy of the prevention enough that we're okay with some people considering it this way, or do we need to do kind of public health messaging to clarify that that's not the purpose, although if that's the reason people want to adopt it in the first place, now we kind of have to decide which one we want to be happening.
Mm-hmm.
Awesome. Okay, so this was kind of actually close to the end of the talk, so we can keep chatting about that or other issues. I just wanted to kind of wrap up by saying, one of the things that sort of came out to me as someone who had not previously been terribly focused on health in specific, but more on security and privacy, is that, throughout this project, what we kept coming back to is that responsible data use isn't just about privacy, right? It's about privacy and providing technology that sort of respects users' preferences. What do they expect to get in exchange for giving up their data? How well do they expect it to work? What kind of benefit do they expect to receive? What kind of transparency do they deserve to have into whatever technology it is that's using their data. And so that's just sort of a frame that we have been taking into some of our other work to think about, how do we build kind of responsible technologies in addition to just kind of private and secure ones, which is a piece of responsible data use and technology, but certainly not the whole picture. Absolutely happy to take more questions now, or just talk kind of generally about contact tracing apps.
Okay, thanks, Lisa, for this really extremely interesting talk. So maybe I have one question. So in the centralized apps, a central problem I think they had was that people who were diagnosed refused to upload, the keys basically. Did you look into that?
Yes, so we did not focus on centralized apps beyond the very, very early research, because we were focused on the US context, and there was sort of this quick pivot to decentralization. But there have been studies, like particularly in France, where there was a centralized app, and upload was absolutely an issue, and was one that people articulated in sort of our early research. So certainly the concerns that kind of privacy researchers had around centralization, we did see echoed, maybe not in the same, technical detail, but the concept of sort of surveillance and who's going to have access and who's going to find out and what are they going to be able to infer, those concerns we absolutely saw. And even in kind of the work that we did with BART in Belgium, right, which was a decentralized app, but it was an app that had an extra step where you could decide whether or not you wanted to allow your data to be used for contact tracing. In the study that we conducted, we did have a couple of people who did not go through that extra step. All of the folks that we spoke with had not done so more out of kind of usability. It was like one more acknowledgement. And in some cases, they thought, like by installing the app, they had already given that consent. But they did speak about sort of others they knew who had had hesitance because they were still worried that others might be able to infer it was them. And in fact, people who had been using the app who we interviewed tried to do that, right? Like they tried to do this sort of retroactive, if they got an exposure notification, they were like, oh, okay, I know I went these places. I know this person isn't sick. Maybe it's this person. They tried to do that detective work. And so that's absolutely like a big risk in these apps, I would say, kind of in general. And that's something where, the more people who adopt, the harder it is for folks to do that kind of thing. But I can absolutely understand, and the data echoes why people would have that concern.
Another one. So you talked about false positives. Now, false positives, I guess, doesn't mean that you're not, that you get the warning, but you're not infected. It just means that you're somehow warned despite not being in proximity. So how do you even measure that? Or do people understand this distinction? This is kind of very delicate.
That's a great question. I'd say from the research I've read and from the research that we've done, people's conception of accuracy was pretty much just at the level of like, I got exposed and it didn't tell me, or I didn't get exposed, but it told me I did. Like that's sort of where they're at. Obviously, from a technical perspective, there's more nuance there. And like some of the conversations we had with, say, Apple was about like, okay, what if people wear the phone in the front pocket or the back pocket or in a purse, or all of these things can change, right? The proximity detection. People definitely did not have that conception. And I would say their conception of kind of the mechanism through which decentralized apps were working, right? Like or maybe not just decentralized, but Bluetooth-based apps in general wasn't great. So a lot of people, even in a decentralized setting like Belgium, had the mental model that it was like GPS location-based. And I think that's just because that's what makes logical sense to them. And that's what they've seen in other apps that they use, right? Like Google Maps or whatever it is.
Any questions from the audience?
Ooh, sorry.
I have a question. Like, what I found really interesting was the study design. So, Marcus told us about numeracy, and that you should not, like, that people are bad at understanding percentages and so on. Because I mean, also, like, if you're not doing this kind of scientific work, it's good to communicate your findings and so on, right? Are these, what I wanted to ask, are these things like somehow standardized so that you, for example, say always like 100 times in a year? Because like in this very specific situation, like if I'm a law-abiding citizen and I'm supposed to quarantine after I have a contact, I will have difficulties having contact with 100 infected persons during a year. So yeah, could you like somehow build up on these things?
Yeah, absolutely. So yes, there is sort of guidance on what to pick as the denominator there. So the reason that we went with out of 100, and most of the literature suggests that for sort of percentage type situations, is that when they've done sort of mental models and they have all these little tests that they do with people. When you use that 100 denominator, people's perception is the closest to what the percentage really means. So if we had said like, right, if we wanted to get them to 70%, if we said 7 out of 10, their perception is probably closer to like 80 or 90% there, just because of the denominator. And so similarly, if you put something out of 10,000, even if you say it's like, 4,000 out of 10,000, people still think of it as small because 10,000 is such a big number. So there is actually a big literature around like picking these denominators, and that the reason that we picked 100 for all of the accuracy things was because we were looking at kind of 0 to 100, like the full range of accuracies. And then in the privacy case, we used 1,000 because people's perceptions were clustering around that kind of 1 in 1,000 range. And so if we had picked something much bigger or smaller, we would have sort of thrown off their perception, because they use the denominator in some ways just as much as the numerator in terms of how they perceive things.
Thanks.
Mm-hmm.
Other questions? Otherwise, I have another one. So you indicated that people, are good in the sense that, they care much more about the public good than about their, own profit. But you could challenge this and say that why do people not want to be maybe they don't perceive being informed that they have a contact as being a good thing, because it typically means that they have to self-isolate or something, whereas if they just don't use the app, they wouldn't have to do that. I mean, they would endanger other people, but they wouldn't do it willingly, so they would could justify it for themselves. So is this really, are people good, or is this more like a...
That's a great question. So I certainly agree with you in that I wouldn't necessarily take it as a good sign about society. I think that my hypothesis here, honestly, is that people are pretty intuitive about thinking through these things. And so when we think about using a contact tracing app, we think, how much good does it do me to know that I'm at risk? It doesn't really do me that much good. Like, aside from knowing not to go see my parents or whatever, it doesn't really help me that much, right? I'm already exposed. At the time, there were no treatments. It's not like I can go get pre-treated or something like that. And so my hypothesis is this has more to do with people's kind of logic, that like, if I use the app, what it really does is make me not go expose other people and therefore reduce cases more so than it really helps me. I do agree with you, though, that that's a great point, that kind of by framing it as individual, we're also reminding them of their individual responsibility for quarantining if they use the app. And so that very well might be a big part of why that framing was less effective. Yeah, that's a great point.
Yeah, I was thinking maybe, you could set up the app in a way which says, if I get infected at the end of the day, inform everyone who wants to get infected, but, I just don't inform me at all. No, it's kind of, it might, it's a selfish setting in some sense. Don't inform me, because if you inform me, I will be forced to self-isolate. On the other hand, if people use it only in that setting, fair enough, right? It's better than not at all, but it's very awkward. Somehow we have like the asshole setting, basically, but not okay.
That's a really interesting point, and I think you get at, what I've talked about here is sort of how the app was conceived by experts, right? Like, even the framings that we have are in a way sort of normative, right? It's for your risk or for reducing case counts. And that's kind of how public health thinks of it. In some of the follow-up work that we did, we actually found that a lot of people, like in Belgium, ended up using the app basically as a test results app. So they found that they got their test results faster through the app than they did through the medical system. And so that was primarily why they used it. And if they ended up being exposed, then maybe they'll press the button to send it on. But mostly it was for test results. And that was a genuine individual benefit. And so I think to your point, right, like this gets at also the other question that I think it was Marcus that asked, you know, well, are they actually good? Like, should we be encouraging people is sort of how do we trade off? Like, well, if you don't have to self-isolate, but we do know that you're exposed for statistics and for informing others, is that sufficient? Or if you use it for as a testing app, but with the option to do contact tracing, is that sufficient for the government to support development of the app, et cetera? There's a lot of questions there about how we could frame these differently from kind of the normative public health model.
Oh, because I was thinking myself at some point, I had the app, but I was thinking, look, if I get the warning now, I cannot do this important thing next week because I will have to self-isolate, even though there's probably like a 1 in 100 chance that I actually have it because I have a mask. I'm very conscious about these things. So, it's tricky.
Yeah.
But then if you get the warning, you can't do anything, right? If you actually have it and you had the warning, then okay. Any other questions? Maybe one more and then.
Yeah. So. Thanks a lot first for your talk. So I wonder, at the beginning you made 2 classes. You said that they're the experts and the users. So I'm wondering, where would you place industry? And what could be potential interest of industry to push this topic further than it is actually useful for the users?
Yeah,
so
that's a great question. And so that's perhaps one of the failings kind of of this moral philosophy framework is when it was first developed or in the settings they were thinking about, at least the literature I've read thinks less about sort of either malicious actors or actors with sort of a goal to not necessarily do the thing that benefits society. And that was absolutely right. Where to place them is an interesting question, because in this context, we saw industry propping in, and industry, not health industry, right? Tech industry. Yeah, and arguably they're not experts in public health, maybe in technology for surveilling people, but not necessarily public health. And, a lot of public health departments and researchers were not pleased with the developments that they made, right? It wasn't in partnership often with public health. It didn't build on the concepts of trust and the kind of efforts that public health thinks are important for contact tracing and that research shows are. And to your point, right, is this just kind of industry getting more embedded in our health system or sort of trying to showcase themselves? We didn't focus on that piece. We had conversations with various parts of industry that was working on this and have written some op-eds sort of about what could have been done better. I would say that often is a space for experts, maybe more so than descriptive end users, to kind of speak up. And even end users had opinions, right? They were not overly supportive of tech companies being the ones to develop that. We saw a lot of open answers about sort of like, I don't need one more thing watching me from a tech company. And also like, why are they getting in the place of kind of public health experts or who I would expect to do this? So there's absolutely kind of a governance angle here. And you could certainly argue that by helping get people to adopt these things, we're sort of embedding them further. My argument would be that at the time, the public health benefits and kind of the way that public health departments chose to implement the apps, they did have some control over it, meant that it was in sufficient alignment with sort of their governance models and population and et cetera, that it was good to help them get adopted. But I think that there should be and are starting to be, as far as I know, a lot more conversations about moving forward in the future. Should industry be at this table and how so?
And I mean, in the end, it will all come to the question of what the industry decides to do here, right? Because to my knowledge, we will also need quite good phones to make, especially proximity measuring or distance measuring work kind of reliably. We need new generation phones. So if I were in the industry and profit maximization was my goal, I would try to create an atmosphere of, well, fear maybe, that if you do not have the app, you might be worse off than if you have it, which then causes people to buy newer phones. So I'm just, this is just a thought experiment. What do you think of that? Is this, or can I throw this off the table, this argument?
Oh, I think you can never throw anything off the table, right? We wouldn't be security researchers if we did not think of the outcomes. And I think, I mean, to, underlying sort of what you're thinking about there is the level of control that tech companies have through these phones, right? So there were definitely conversations that health departments had with phone manufacturers saying, we really need data XYZ in order to do things effectively. And the phone manufacturer was able to say, no, we're not willing to do that, even though they use that very same data for their own commercial purposes, right? And there was really not much that those public health departments felt empowered to do, and they didn't have the data themselves. So yeah, I think that's absolutely a huge concern and something that has gotten less conversation than perhaps it should throughout this process.
Okay, so then let me stop the recording. Okay, thanks again.